All right, so the next solver on the list of new videos here that needs to be made for BloodHound version 2 is the inflection solver. Now, nothing has changed with the inflection solver. Actually, in fact, for BloodHound version 2, none of the solvers have changed. They all still do the same function, right? It's just that with BloodHound version 2, right, BloodHound looks a little different, so it kind of puts people off here. But as far as the functionality, right, a crossover is still a crossover. Just because there's BloodHound version 2 doesn't change how crossovers work. Same with the comparison, right, and the same with the inflection solver. I don't want to get too off track, but the one solver that has been rearranged a little bit but still functions exactly the same as the support resistance solver. But anyways, that's another video. So let's go over the inflection solver here, see what that's about. So yeah, the inflection solver is probably the second simplest charting condition out there, right? I guess the first, the simplest charting condition would be just the bar direction, right? That's probably number one. And then number two would be the inflection solver, right? I don't know. Maybe some people might say maybe the bar length is the second, but bar length and inflection are running neck and neck for number two as far as simple charting conditions here. And so an inflection, mathematically, an inflection means a change in direction, right? So actually, I probably should use the arrow so we know what direction we're going. There we go. All right. So if you change direction, right, that point is an inflection, right? So that's the inflection point. So that's all an inflection is on a chart. Is you're going from either your direction is either going up and then you're changing to going down, right, or vice versa. You're going down and changing to going up. Obviously, on a chart, you can't do this, right? You can't have inflection points where you're going forwards and then you're going backwards, right? That doesn't exist on a chart, right? So it's the x-axis is time-based. So with charting, inflections are always going from down to up or up to down, right? So on a chart, to simplify it even further, an inflection is just a reversal from going up to going down and down to up. Right? So it's really just that simple. So, right. So the default here for the inflection, the default indicator is the SMA 14. So let's, I guess, go ahead and throw that on the chart. There we go. Oh, no wonder. There we go. It's an SMA 30 on my chart. Okay, let's change that period down to 14. All right, so I was wondering why things were not matching up, because I could see, right, there's a reversal up and a reversal down and a reversal back up, right? So if things don't match up on your chart, it's inevitably going to be because, the indicator on your chart isn't matching what you have set up in BloodHound. So there you go. So putting that SMA back to the standard 14 period will fix everything there. There we go. All right, so now we have it, right? So there you go. Simply put, whenever the SMA, reverses directions from going up to going down, right, and then going down to going up, so on and so forth. And let's drop another one on here. So, something that gets commonly used is to check when price, aka the closing price, reverses from up to down. So that is seen a lot here, and actually I need to change the input type. So from indicator to price, and there we go. So now you can see, right, whenever the down bars, switch to an up bar, right, we're going to get a long output. And then, so we have up bar, and then we get a down bar, and so we get a short output. And then we reverse again to get an up bar, we get a long output. And so up bar, well, actually, it's not necessarily that it's an up bar, but it's that the close of the bar is higher. Because remember, this solver is looking at the closing price of the bar. Yeah, so it's not necessarily that it's a down bar to an up bar. It's just that the bar close has, moved up. And so you're typically going to see that, you're going to see the long and short signals corresponding to a down bar and up bars. But that isn't necessarily always factual, right? Because you could get a gap. Yeah, you could get a gap down, and then the bar technically closes up by one tick, but you don't actually get a long output. So, I guess looking at the chart using a candlestick type here can be a little misleading because, right, the inflection solver is not looking at the candlesticks. It's only looking at the closing price. So a better way to look at this would be line on close, right? So there we go. So that is what the inflection solver is actually analyzing there. So we can see, right, whenever the line reverses down, we get a short output. And then when that line reverses up, we get a long output, right? And that reverses down to short, reverses up to a long, reverses down short, reverses up to a long, right? So on and so forth. So, yeah. All right, so let me put this back. There we go. And let's see here. What should we take a look at next? Yeah, let's add something like the stochastics indicator, an oscillator. All right, this could be the stochastics. This could be the ADX indicator, right? The MACD indicator, whatever, doesn't really matter. All right, so now let's grab an inflection solver of the stochastics. So we'll change the indicator input there. There's our stochastics, and yeah, so it's all the standard settings. And I am showing the %D on the chart. And, as hopefully as you all expect, right? So there you go. When the stochastic rolls over, we get a short, and then it rolls back up, we get a long, so on and so forth, right? So again, the inflection solver is pretty simple to understand there, right? So the key use, I guess a way of summarizing, when would you want to use the inflection solver versus when might you want to use the slope solver, right? So obviously the inflection solver is showing you when the slope, changes from sloping up to changing down, but it only shows you that on the very first bar, right? You can see, so the stochastic is still sloping down, but there's no output, right? So if you need to know if the indicator or price or whatever is still moving downward, then you would want to use the slope solver, right? So yeah, so to put what we're seeing visually to words, the inflection solver only shows you the first point or the first bar when the direction changes. So just like a crossover solver, right? So let's see here. Let's put the list of solvers here, right? So the key difference between the comparison and the crossover is the crossover only gives you an output on the crossover point. But if you want to continue to see if let's say if price is above a moving average, you would want to use the comparison, right? The comparison will give you an output on every single bar when something is above something else or something is below something else. Whereas the crossover only identifies the very first bar when something was above something else and then it crossed down below something else, right? So the crossover gives you an output very similar in nature to the inflection solver, where you only see the first point when something changes, right? So from that standpoint, the crossover and the inflection are similar in nature, whereas if you need to see a continuous output, then you would want to use the comparison or the slope solver, so that way you get a continuous output when something is above or below something, or if the indicator is continuously sloping down or continuously sloping up. So, all right. Let's see. So one last example here is I'm going to put the swing indicator on the chart. All right, swing highs and lows. Let's see. Yeah, I'm just going to use all the standard settings. All right, so for this one, I'm going to plug in the swing highs and lows. Let's see, how do I want to approach this? Yeah, I'll generate a long output when the swing highs move higher, right? So that would be the widest tops. Or if the swing lows step down, right, move lower, then I'll generate a short output. Right, so here we have it. So we have a swing high right there, and then it steps up, right? We can see we get a long output there when that swing high steps up. But if that swing high steps down, right, there's no output there. Yeah, here we go. Swing high, and then it steps up, and we get a long output. Same thing, right? And so the reverse effect for the swing lows here. So if a swing low steps down, we get a short output, right? So and so I'm illustrating the swing highs and lows indicator because, right, it's plotting flat, right? So this is flat. It's not, it's not going from up to down, right? Like, it looks like I'm missing some data here. Actually, oh no, that was, yeah, I think that was the economic report. Okay. So again, yeah, so the point being is that, the inflection solver can work on indicators that plot flat in nature, so you can use it to identify when something like a swing line steps down or steps up, right? And we can reverse this. So if we wanted to, we could reverse this. So let's go into the indicator settings here, and let's reverse this as well. Right, and so there we go. So now when the swing highs steps down, now we get a short output. And if the swing lows step up, right, we get a long output. Let's see here. So now let's go over some of the internal settings here for the slope solver. I'm sorry, for the inflection solver. Let's connect. Let's kind of go back to the basic one here. All right, so the input here pretty pretty right. This pretty standard. So right, obviously the input is common to all the solvers there. So right, that just determines what data you want to analyze. To have an inflection point. So now the settings here. So this look back period basically allows you to extend a inflection forward in time, right? So if I increase this to 2, now we actually get 2 outputs there on 2 bars, except where, let's stretch this out here, right? So we can see our SMA, right, reversed up, we got a long, then it reversed down, and then we get a short. Now, right, so obviously there was a quick reverse up, reverse down, and so the extra output only lasts until the next inflection point. Right, so let's increase this to 3 there. Right, so now we have 3 outputs there. But again, if a inflection in the opposite direction comes along, right, that's going to end the extra outputs there. Right, so again, using this reversal up followed by a reversal down, right, you're only going to get, or I should say the extended output is only going to last until the next inflection point there. So the opposite inflection will end that extended output there, right? So if you really needed to, say, take this reversal up, right, take this long output and extend it forward, regardless of that reversal down, then that's when you would have to grab a function node to do that, right? So again, you could use the look back, or you could use the signal extender, right? In that way, right, and that would force the signal continuation forward there. So, there's a couple of solvers that do have this look back period, and they all They all have the same behavior, in that if the opposite condition comes in, right, the look back period gets cut short, right, it stops, discontinues, right, and then the opposite condition starts plotting there. So so the look back period just kind of provides a simple way of extending the inflection condition forward in time for maybe something else to follow up with. So like, let's see here. Yeah. Interesting that it's kind of hard to see, but yeah, the SMA, even though bars were going up, the SMA did inflect down, and so maybe if you're looking for a moving average to reverse down, but also you want to match it up with the bar direction being down, right? As we can see here, we actually got two up bars even though the SMA reversed down. And so if we're looking for a down bar, after the SMA reverses down, then as we can see here, right, you would need to use the look back period. So we can take the inflection condition, extend it forward until we actually get a bar down, right? So, yeah, I'll just build this real quick. Connect those two together. There we go. So now we have a short output on the down bar after the SMA reversed down there. So, yeah. All right, let's get rid of that. And let's see. All right, so let's continue down the list here. So next is just the outputs. So slope in direction. So again, an inflection is a change in slope, right? Another way of putting it, right? Yeah, the slope in direction means that the output, actually, let me turn the period back down to 1, right? So, so obviously, yeah, let's just kind of take these simpler examples here, right? Obviously, we're getting, so when the slope reverses down, right, we're getting an output in the direction of the new slope, right, that reversal down. So now the new slope is downward, right? So, let's shrink that up a little bit. There we go. There. So, yeah, so the output is going to match what the new slope direction is using this output, right? Next one down on the list here, right, is no inflection point, right? So now you're going to get a long and a short. So again, this is not a slope solver. So even though the SMA is sloping down, the output is just saying, yeah, okay, there's no inflection point, right? Obviously, where the inflection occurs, right, there is no output, right? So this is giving us kind of like it's not a actual invert, but I guess you could describe it as like a complete reversal, of the slope in direction. Yeah, and the name pretty much says it all. No inflection. Okay, yeah. These are all the bars with no inflection, and of course you're going to get a long and a short output. So turn that off. Now let's see. Actually, I'm going to skip down to the slope against direction. And let's set that to 1. So slope in direction and slope against direction. Again, there's other solvers that have this type of output, but essentially that just kind of reverses the output. So once again, the SMA rolled over and now it's sloping down, but we're getting a long output, right? So pretty straightforward, right? SMA is now sloping upward, right? It rolled up, sloping upwards, and we're getting a short output. So kind of like as was explained in a previous question, this is how you can reverse the outputs here from the standard output. So using the slope against direction. All right, so let's put that back in place like so. And again, for a lot of nodes, using the new swap modifier button here will do the same thing, all right, as using the against direction output. Yeah, for the most part, yeah, the against direction will give you the same results as using the swap button, but don't count on that being 100% of the time, right? So I can't think of any situation off the top of my head, but yeah, but just know that there might be some solvers, some situations where the slope against output might need to be used instead of using the quick, little swap button there. So, all right, let's put this back to normal. Okay, so now let's go back to the output decreases as, and we're going to have to stretch that out, as inflection ages. So this is this goes back to the fuzzy logic capability of BloodHound, right? Yeah. So this kind of goes back to, yeah, BloodHound's original design here, which is based on fuzzy logic calculations. So the output decreases only applies when the look back period actually has a period greater than 1. So let's put this to 10, like so. Right, so there we go. So now we have some inflection points with a very long output there. And so if you are using fuzzy logic, right, you might want to decay or fade those inflection points as they get older and older and older, right? Older meaning as each new bar is printed. And so let's decrease it by 0.1, which kind of matches up with a 10 bar look back period. And simply put, right, we can see, right, that the output decreases, by 0.1, as as the look back period continues on there. There we go. All right. So let's take a look at this short output, right? So it starts off as 1 or 100%. And then as we step forward, right, each output decreases by 0.1. So now we have 0.9, right, 0.8, 0.7, so on and so forth, until we get to 0.1 and then nothing, right, and then 0. Well, actually, I guess to kind of emphasize, let's increase this to 0.2. Yeah. So there you go. So even though the look back period is set to 10, right, because we have the decrease output set to 0.2, right, it's only going to last for, the output's only going to last for 5 bars, right, because it's decreasing to 0 pretty quickly there. So yeah, there's not going to be very many users that will need this output there, but it is there for those fuzzy logic, system designers. So, and that does it for the inflection solver. It's really just that simple.